All right, guys, welcome back to episode number 3 of Automating Compliance in the Cloud. I hope you enjoyed episode number 2 as we kind of dove into some of the code that you see here on the screen. So if you missed that episode, I will definitely leave a link up top or in the description below. So check that out before you watch this video because we, set a lot of the foundations that we're going to be building on in this actual video. So in the actual CIS framework, we have to cover a few different password policy rules to actually remain in compliance with CIS. Now, those can be found from rule number 1.15 to 1.19. And they basically make you have some sort of password complexity, such as 14 characters, special characters, things like that. Now, I like to do it in a programmatic way because if I have multiple accounts, I don't want to necessarily go through and change the password policy manually for all of those accounts. And I also don't want people to be able to change the password policy without me having some sort of system of record that's going to go out there and actually fix that password policy back to what it should be in order to be in CIS compliance. So today I'm going to be showing you guys how to create a Lambda and the corresponding Lambda role and infrastructure to create a basic password policy that I think a lot of you will be able to build upon. It is very basic, but I think it covers a lot of the core concepts that we want to actually allude to here in this video series. So without further ado, let's hop directly into it. All right, so if you actually come to the AWS console here, you're going to be able to view your password policy by going to the IAM service, then going to account settings. And it should look something like this. So minimum password length of 8 characters, and it has to include some character types, and it must not be identical to your AWS account. So it's really not that complex. And the password policy and MFA are two things that you really need to lock down. They're so simple in AWS, but almost all of your breaches come from some sort of misconfiguration in the password policy. Again, it's the worst thing in the world to be a cybersecurity guy that talks about password complexity because you sound like a broken record, and it's really not all that technical, so people don't normally listen to it. But it is the most basic thing you can actually do to secure your AWS account or your accounts in general. So I really like to just lock this down at the outset so we can move on to more technical and, just a lot more fun things than password complexity. So for this one, we're actually going to be creating a Lambda. So we need the corresponding Lambda infrastructure here that's going to be used to actually build this out. Now, there's a few different ways you can do this. What I like to do is I create the actual infrastructure in TypeScript in my lib folder here in my actual stack. And then I actually create my Lambda in Python in a separate folder, and then I reference that folder. So there's a few different ways we can do that, but one of the best ways here that I think we can is to directly use assets like we were talking about in the last video to actually create that Lambda infrastructure. Okay, so one of the first things that we're going to actually have to do is create a role that Lambda can assume to then do the necessary things that it needs to do. So for that, we're going to actually have to create a role here. And I'm going to call this one the CIS password policy Lambda role. And it's going to equal a new im.role. We're going to pass it the constructor like we always have. And then we're going to capitalize. Let me actually just copy this variable here so I can just capitalize the first letter. A lot easier. Perfect. Wrong comma, sorry. And then from there, we're going to actually have to pass it. Sorry, my autocorrect is kind of filling in. We're actually going to have to pass it some properties. So we're going to have to specify what this is going to be assumed by. And it's going to be assumed by a new IAM service principal. And that's going to be called Lambda in string value. Wish I could type. Lambda.amazonaws.com. I'm going to leave a link for all of the service principal strings that you'll need to actually use the CDK down below because they can be a bit ambiguous, but there actually is a system of record for this. And I think it was created in some open source library, which is really awesome. But from there, what we're going to have to do is we're going to have to actually add a manage policy to this Lambda rule that we just created. And the reason for that is we have to give the Lambda specific permissions to do what it needs to do. Now, for the sake of this video, I'm going to once again give it administrator access. But in the later coming videos, we're going to actually go back through all of our code and essentially refactor it to give the specific roles and really tighten up our actual permissions so that we can have the most secure account that we have, or that we need, sorry. So I'm going to give it administrator access. Let me just make sure I spelled administrator correctly. And that should be all we need to do from a permissions perspective. But now let's actually create the Lambda infrastructure that's going to be dictating how our Lambda is built, what kind of runtime or programming language we're giving it, and other properties that we'll need there. So what we want to do is we want to first import the Lambda library that I have up here. And again, all these libraries can be found in the CDK docs. And from there, what we're going to have to do is declare a variable that's going to hold our Lambda. So I'll call it the CIS password policy Lambda, and it's going to equal a new Lambda.function. And then from there, I'll pass it the constructor. I'll copy and paste this for the string value, and again, capitalize it. And now let's pass it some properties. So Lambda actually has some really cool properties that you're going to need that actually make your life a lot easier when creating Lambda infrastructure. The first one's going to be the actual language we're going to be using. So I'm going to do lambda.runtime, and we're going to say Python 3.6. Sometimes I use 3.7 for the walrus operators, but 3.6 seems to be a really good sweet spot right now for Python code, in Lambda at least. Then I'm going to add the role property, and I'm going to reference the variable for the Lambda role I had up top that gives this Lambda permissions to assume that role and then go do some things that we need it to do. Now, the next property we're going to have to pass is the handler. Now, this one's going to be a bit tough, but before we do this, we actually have to write the Lambda code that is going to then make up that actual handler. So let's actually create a new folder here called Lambda, and let's cd into that Lambda folder. And if you guys are confused, go to the root directory of your project and just create a new folder called Lambda. And then from there, cd into that Lambda folder. And I like to do something like this. So I make a new directory under that Lambda folder for all of my Lambdas. So I'm going to make a dir here and call it CIS password policy Lambda. And then I'm going to cd into that directory. And now I'm going to actually make my Lambda function. So if I code CIS, let's do snake case just because that's what it should be. Let's do password policy lambda.py. So essentially what I did is I made a Lambda directory. I made a directory for my specific Lambda called the same exact thing that the Lambda is going to be called. And then I made the actual file that the Lambda is going to live in. The reason I did that is because when you're using assets, you want to be able to actually reference the directory the Lambda is living in, because it's going to essentially zip up that entire folder for you where all your packages live. And it's going to upload that directly to your S3 bucket that holds your assets, and in turn directly upload your Lambda code to the Lambda serverless service to then run your code. So this password policy Lambda is going to be very, very simple. I think it's a great one for us to start off with when we're just dealing with or just learning Lambda. But the first thing you're actually going to have to do in a Lambda function is define something called a handler function. Now that handler function takes in two parameters called event and context. And when we actually use our event filters and our metric filters later, you're going to see where that comes into play. Event is essentially any event passed to the Lambda, and I'll explain more on that later. But let's just return nothing right now for that handler. In order to actually add the libraries that we need, Ep.3 is essentially the one-stop shop for all Lambda functions. It can get a bit weird with deprecated things such as requests, because Ep.3 constantly has to update new libraries to stay in touch with the other open source libraries there are out there. But within Ep.3, we're going to have to import something called a client. So I'm setting the client equal to the IAM variable just for ease of use. And then from there, I'm importing Ep.3.client, and then I'm passing it a string of IAM. Now, if we come here to the actual Ep.3 library, I can show you guys exactly what I'm talking about here. Let's do library IAM. And again, this will be in the description below. So this is the Ep.3 documentation. If I come to client, I'm going to actually try to create a IAM client or a password policy. So if I come here, let's see, I think I need to update the Perfect. There we go. So I'm using the update account password policy function. And as you can see here, I don't want to get too ahead of myself. I'm going to pass it some parameters in a response variable that's going to actually go out and do what we need to do. But if we come back to our actual function here, I'm now going to create a new function in order to pass it to our handler function. Now you could essentially just create everything under the handler function if you wanted one giant function, but I don't think that's actual great use of the functional programming language that is Python. So let's create a new function here and title it update policy, Close that function, and let's create a try except here. And let's just print that error for the sake of this. And let's return. I think everything should be good there. Sorry, I'm just creating kind of the framework for what we're going to operate within. So with that in mind, the update account password policy function that I showed you before, let's create something called a response variable. And again, this could be named anything you want it to. I technically just name them response because that's what AWS likes you to do, because essentially when you print response, it's going to give you the response to the function that you sent it. So let's do IAM, which is our Ep.3 client up here. Let's do update account password policy. And let's create a function out of that. So here's where we're actually going to pass our parameters or our properties to update the account password policy. The first one that we're going to need, and again, I'm copy pasting these directly from the Ep.3 docs. So when you see me just directly copy pasting, so I don't have to actually type everything out, that's exactly where it's coming from. And this will be down in the description below. So I'm going to first pass it a minimum password length, and we're essentially just going to line this up directly with the CIS Foundation's benchmark controls. So if I come here, 1.19 is ensure an IAM password policy requires a minimum length of 14 or greater. So I'm literally just going to write in the integer 14 here. Like I said, this is going to be a very basic password policy. But it's really just geared towards getting you guys comfortable with what Lambda is and what Lambda can do. I'm also going to need to require symbols. So let's set that to a Boolean of true. Oops, sorry. I don't know why I'm pretending this is JSON. Minimum password length should equal 14. Require symbol should equal true. Let's do require numbers now. Require numbers should equal true. Let's do require uppercase characters. That should equal true as well. Let's do require lowercase characters. Again, this is going to equal true as well. We should allow our users to actually change their passwords here, which is again another part of the password policy that you're going to have to add. If you were to do this in the GUI, you could click through all this perfectly fine. Nothing wrong with it for one account. But to do this programmatically over many accounts, you're going to want to have this all written out in infrastructure as code, in my opinion, because you can see exactly what everything is doing from a DevOps or programmatic perspective. So we're going to require a max password age of 90 days. We're also going to stop people from reusing their passwords for 24 specific passwords. So what that means is you can't use the same password within 24 times of each other. So I can't use, say I use password 123, I now have to have 23 different passwords in between that password and password 123 for me to be able to reuse it again. And I'm going to set hard expiry to false as the last part of our actual Lambda here. The reason I'm doing that is because you should be setting this to true. Sorry, I don't know why I made these all lowercase. I was wondering why that was just erroring. Stupid Andrew, you got to learn your bools, man. Okay, perfect. Okay, so you should actually be setting your hard expiry to true, but there's also some sort of process automation that you have to implement on top of that, because you don't want your passwords for your users just expiring without them being able to do anything about it or being updated about it. So we're also going to be creating a Lambda later on in the video series that actually reaches out to users via email and tells them their password's about to expire and then gives them a link to the console to sign in to then update their password. I know that seems a bit redundant, like users should just be updating their passwords on their own. It's so simple, but this is the bridge that DevSecOps tries to connect, because we try to make security not a hard thing to interface with. We try to make it very user friendly, and I think that's kind of the future of security, especially in the cloud. So if we want to be able to print our response in the actual Lambda console, I always do that, and then what I do is I return the response to then close out the function. And adversely, if I'm going to add my except block here, and I know this is erroring right now, but that's just because I don't have Ep.3 technically imported on this actual machine. Don't worry, it'll work perfectly fine, but I highly recommend you setting up a virtual environment when you're using Ep.3 because it can be a bit cantankerous. So if I'm actually finishing out my except block here, just so I want to see any errors that come back, I'm going to return a false, and then I'm going to say some sort of string that's going to help me out here. Can't update password policy. Let's close that, and let's concatenate a string with the actual error that's being handed back to us. Now, again, if you're confused about what I'm writing here, definitely check out some sort of Python introductory course. I can leave one that I actually used about 6 years ago, or I recommend to people. It's really great. I think it's from Free Code Camp. But if this is looking complicated to you guys, I highly recommend you learn Python before you come in and actually try to write infrastructure as code. So now that our password policy Lambda is finished, we actually have to go back to our infrastructure and we need to reference the handler. Actually, I think I missed something here. Yeah, sorry. I need to put the update policy function in my handler so it's actually called perfect. That should be good. Now let's delete this return because the policy is actually going to return it itself. And we should be good to go on that. Perfect. There was something going on with a linter that I had on Python. I know everyone that uses Vim is going to roast me right now for VS Code extensions, but definitely get a linter for Python. Mine just bugged out for a second and showed a bunch of errors that weren't there. So everything is fixed now. We're good to go. Let's go back to our actual infrastructure and reference the thing called the handler. So the handler is going to be the same thing as the name of your actual password policy, meaning the function or the file that you created to hold the Lambda code itself. It's going to be the same as that. So if I copy paste the function code that I had, CIS password policy Lambda, see you up here, CIS password policy Lambda, all I have to do is add a dot handler on the back of that. Now, in order to explain this, I'm going to have to show you a few things. So the first part before the dot handler is going to be the actual name of the file, like I just said. But the dot handler comes from this here. So I always name my handler function just handler because it makes it super easy to reference it when you're actually creating infrastructure here. But now I need to actually tell the Lambda infrastructure where it's going to be grabbing the code from. And this is where assets come in, which is really cool. So I'm going to add a property called code. I'm going to say lambda.code from asset. And then I have to actually add path.join. And I'll explain all of this in a second. Dir name, what is that? 2 underscores? I think it's 2 underscores. Dir name, and then I have to actually pass the path itself. So the Lambda folder, and then the actual folder the Lambda lives in. You notice how I don't actually explicitly reference the password policy lambda.py. I just referenced the folder, so anything in that folder is going to be uploaded along with the Lambda. And in order to get the path in TypeScript, at least, you need to import a library called import path, just normal path library. I'm not sure what the equivalent is. In Python, it's probably like pathlib or something like that. But import that definitely because now it knows directly where to not only look for the code, but where the code is going to be referenced from in the handler. It knows what kind of programming language we're using, and it knows what role it should be using under that to give it actual permissions to run. The last thing we're going to have to add is something called a timeout property, and that's going to be using cdk duration.seconds, and I'm just going to pass 60 seconds for this actual timeout itself because this is a really, really small Lambda. It's going to run regardless, and it's definitely going to be done within 60 seconds. Now, the reason you want to add a timeout to the properties of your Lambda is because when you actually run your Lambda, the costs that you incur are going to be from how long your Lambda function runs. So if your Lambda function has an never-ending for loop, it's going to run indefinitely, I think for about an hour, and that could incur a ton of costs. So what I'm essentially specifying here in the properties is that if my Lambda function, if it runs for more than 60 seconds, time it out because something's clearly wrong. And then if I go back to my password policy, it'll print out the actual exception that happened here, and I'll know exactly what went wrong in my Lambda. Now, on top of this Lambda function and all of its actual infrastructure should be done. But there is one thing that I want to add to this to actually create some sort of cron job. So if someone updates the password policy aside from what I specified in the Lambda, my cron will come through bi-monthly and it'll actually update monthly, and it'll actually re-update the password policy to what it's supposed to be, therefore kind of keeping your account in compliance regardless of what users do in the actual GUI. So in order to do this, I'm going to have to create an event handler or an event rule, and that's kind of Lambda's infrastructure to create cron jobs. So again, I'm going to create another variable here, create CIS password policy Lambda cron. This is going to be a new events dot rule, and I'm going to pass it the constructor. Let me grab this. Let's make this a capital. And then I think we need to actually add some properties such as a schedule. Now, before we do that, let me show you where I got this events library from. I just grabbed it again from the CDK docs and I imported it up here. And then I'm also going to need to import the targets to actually specify where the target for the cron rule is going to be added. But I'll show you that in a second. So if we add this here, we do a new events.schedule, and we're going to add an expression. Now this is where a bit of regex comes in. It's not really regex, but it's essentially Lambda's cron regex. And I'll leave a link for this down in the description below. But for the sake of time, I'm just going to copy this in here right now. Again, it's not complicated, but this is the cron job for running on the first of every single month. And AWS does a really good job in kind of laying these out and showing you exactly what they do. So again, I'm not really skipping over something that's that detrimental to the actual project itself. I always hate when tutorials do that, when they're like, yeah, you guys know this, and they essentially show you something that's super complicated, and you're like, yeah, we don't know that, buddy. But yeah, so if we add this, now we have an actual scheduled expression for when this Lambda should run without us manually invoking it. But we need to add a target for that because the cron doesn't know what to actually look for. So if we come here, we do lambda.cron. Now we add a target, right? And we specify some properties. So we have to say new targets. And again, this targets library comes from me importing it up here just in case you guys were wondering. We're adding new targets dot, and then we're specifying that it's a Lambda function we're adding. And all we're going to do now is pass the actual CIS password policy Lambda as a parameter to that function, and we should be good to go. So let's see if this actually deploys by doing a CDK list to check for any hard errors. Oh, sorry, I'm in the wrong directory. I always do that. Always be in the root directory when you try to CDK list. So, perfect. Now let's actually deploy this and see what happens. Let's do a CDK deploy. And here's the changes that we had. You'll see that we're not deleting anything. We're just adding a bunch of stuff. And let's hit yes on that. And while that's actually deploying, I want to show you guys what the password policy looks like now. I know I showed you guys this before, but here's what it looks like. Very basic. And we should actually see the Lambda come into the services here. But once that deploys, I will see you guys in a minute. All right, so now that we see our actual stack deployment was confirmed, it's successful. We have the stack on if we want to use it. And again, this is the same stack that we deployed in the previous episode. All it did was add the new features that we just added and deployed only those. So it knows within stack memory what you already have in your account and is deployed and what you're newly deploying. So it doesn't just redeploy the same thing over and over again, except for S3 buckets sometimes because of the way that they're actually versioned. So if we come into our Lambda functions for our services, we see that we now have a function name called Cloud Compliance CIS Baseline CIS Password Policy Lambda, and then some hash numbers at the end of it. We have the runtime, which is Python 3.6. Again, the package type is zipped because we actually specified the folder itself. And if we click into it, we see our code. Boom, directly there, all the code that we just wrote. And if we come into the actual configuration, we should be able to see that now we have a timeout of 1 minute set. So again, this Lambda is going to run for a minute. And if it errors, it's just going to time out. It's not going to run forever and actually cost you a ton of money. That's why timeout is so important. If we come to the code and we test it, we should now see that our password policy is going to be changed by this Lambda. So if we run it, We add some test data because that essentially acts as the cron expression for us right now. But again, at the first of every month, this Lambda is going to run by itself, and it's actually going to update whatever changes were made. If there were no changes updated, it's going to finish in about 0.3 seconds and cost you virtually no money at all to run this. It's just something that helps you keep your password policy in compliance. And the actual cron job itself can be specified to run more frequently if you're having, continued issues with your users actually changing your password policy. But let's actually create some test data. Let's run this, and it should run successfully. Now, if we go to our IAM user service and we go to the account settings again, this password policy should now be in compliance with CIS, and it is. So we have a minimum password policy length, or minimum password length of 14 characters. It requires an uppercase character, lowercase character, a number, a non-alphanumeric character. It expires in 60 days. Perfect. It allows users to change their own passwords, and you can't use the same password. It remembers your last 24 passwords. So again, you can update this very, very easily by just coming in here. Say you want a 17 character password. You literally just do that, and you can deploy this out to multiple accounts, right? At the end of this video series, I'm going to be showing you guys how to set up account pipelines so that if you create something in one account, you can then deploy it to all of your accounts at once. And it's a really great way to set up CI/CD and also just to have a distributed security program that is very user-friendly and programmatically created. So I know this Lambda that we just created was very, very, juvenile, but I think it lends itself a lot to people that are actually just trying to learn CIS compliance and Lambda as well, and maybe a programming language as well. I'm really trying to keep this as simple as possible so you guys can learn multiple things at once. And again, automating CIS compliance is a huge factor in getting a job. I think a lot of employers will really be happy if you kind of come to the end of this video series and you have a GitHub project that shows all of the work that we've done here so far. It not only shows that you're aligned with a compliance framework, it shows that you're thinking about, business processes as well as the cool technical stuff that we all love. So if you like this video series, definitely consider giving it a like down below. I really appreciate you guys all for watching. Leave a comment if you have any questions, or join the Discord if you want to have more of a long form discussion on this. Again, follow me on all my socials in the description below, and I will see you guys in about a week for episode number 4. Take care.